Listen to this star. You just heard the sonification of a red giant's surface brighten and dim as it expands and contracts. Red giants are gigantic stars, hundreds of times the diameter of our sun. Their light appears red because of their cooler temperature. These large, puffy stars expand and contract like a bowl of jello tapped with a spoon. This movement, called oscillation, changes the star's overall brightness. Measuring these oscillations is called astroseismology. You can hear the star's cool, slow movements and the low pitch and slow modulations of the sound. The song changes as the oscillation causes the brightness to change. Different from red giants, white dwarfs are very small and dense, an entire star the size of Earth. White dwarfs are so hot that their light appears white. Remember the huge, cool red giant and how it produced a deep sound with slow modulations? What sound do you think the tiny, hot, quickly oscillating white dwarf will make? Let's listen to a sonified white dwarf to find out. The white dwarf's light curve sounds high-pitched and changes very quickly, the opposite of the deep, slow red giant. Why is that? Because white dwarfs are hotter, smaller, and denser, the waves of gas pressure and density inside the star travel more quickly than in the red giant. These oscillations allow us to measure properties of the interiors of the stars themselves, even though we can never visit the inside of a star. Astronomers can determine if a star is a white dwarf or red giant by looking at its brightness changes, or, in our case, by listening to them. Dense, small, and hot? Puffy, big, and cold. You probably heard other noises too. These may have been caused by other things changing the star's brightness, light from nearby stars photobombing our measurements, or the telescope itself, since no instrument is perfect. The extra noises might even be something new, waiting to be discovered.